Hey guys, so in this video I want to show you how to work on log-based problems. So this is called common log or just log. If you see ln, that's called natural log. So let's see. So I have a formula of what to do in the yellow. There's two formulas. You see how it says or with the circle on it? Both of these formulas are the exact same thing. So let's go ahead and start on this. So what you want to look for is u. You want to find the derivative of u, and you want to find a, the letter a. So let's see. In this, we're going to focus on the parentheses for u. So u is x. The derivative is 1. The derivative of x is always 1. That's why I came up with 1. So a is always going to be that little tiny number in the bottom, which is a 4. I want to use the formula in the top. We can do both versions to show what the end result is. So it looks like there's a 1 in the numerator, and then we have u, which is x, times, you write ln, you do a parentheses, and then you put the 4 in there. That little tiny number in the bottom is called a subscript. Okay, we're going to multiply this fraction by the derivative, which is 1. The derivative of u, or x, right? So let's see, we're almost done. We're going to try to put this all together. So when you're multiplying a whole number against a fraction, you're going to put an invisible 1 in the bottom of that whole number. So now we're going to multiply everything in the top together in the numerator, and we're going to multiply every single thing in the denominator. And there's a lot of stuff there. So we're going to do x, l, n, 4. This is the answer right here. This whole entire thing. That's the answer. I used this very first formula. Let's try the second one right here. Let's try the second one. So we have the derivative, which is 1. Then we have u, which represents x. Then I have ln with a parenthesis. And then inside the parenthesis, we're going to put a, which is going to be 4. Right? This is the answer. Both of them are exactly the same because both of these formulas in yellow off in the corner are the exact same thing. They're just written in two different ways. Personally, I prefer the top one because it just gives me a better visual. But I noticed most people like the bottom one. Let's try a different problem. Okay, so I have a similar setup, but now I have an nth on the top, right? So let's do our bookkeeping. Even if you're not sure, just do the bookkeeping just to kind of get the ball rolling so you feel a little bit more comfortable with all this stuff. So let's see. I have u, and what is u? Well, I think a better way to show you this would be to start with step 1. You're going to take this 7 and you're going to move it to the front. So it's going to look like this: 7 log 3x. This method is a little bit easier to follow, in my opinion. Right, so I haven't done any math. This is just the setup. I'm simply rewriting the problem that they gave us. So let's try to see if we can work on the setup this way. Right, so here's my bookkeeping in the corner. I have u. Now u is just x. There's no longer that 7 because we moved it to the front. So I have x, then the derivative is 1, right? The derivative of x is always 1. That a is going to be a 3. That's subscript. So let's try to see what's going on. I'm going to move the 7, right, to the front. And then we're going to work on the second part. So it's going to be a 1 in the numerator. The u is an x. Then I have ln 3. Let's put it all together. Let's give that whole number of 7 an invisible 1 in the bottom. And we multiply the top, which is 7. And then we multiply the bottom. This is pretty crooked here. Okay, which is x, l, n, 3. Okay, perfect. This is the answer. Right here. That's totally the answer. Let's do one of these problems that has a lot of stuff inside the parenthesis. That way, we can see this in a different perspective. This one's a little bit interesting. So let's do our bookkeeping, right? We have u, then I have the derivative, and then I have the letter a. So the u is literally every single thing inside this whole entire parentheses, right? So that is going to be x squared plus 1. The derivative is going to be 2x 1 plus 0. That 1 is a constant, so it's a 0. The a is a 3. I got it from right here. And let's see. Let's try to set everything up together. So in the top, I have a 1. And then at the bottom, I have u, which is x2 plus 1. We're going to put that in parentheses, times ln3, right? Times the derivative, which is 2x. Let's go ahead and put that invisible 1 in the bottom just to make it easier for us, right? And I have this right here, which is, let's put in the bottom, I have 2x, and then I have everything in the denominator, which is x to the second power 1 ln3. So here's what's interesting about this. This could technically be the answer, right? This could be sufficient. But what you can also do is you can distribute the denominator. You can distribute. So we keep the top the same, the numerator the same. X to the second times ln3 is going to be x second ln3, right? Plus, I got the plus from right here, right? Because we're just putting these together, and then I'm putting the second part together. 1 times ln3 is going to be ln3. So I kind of messed up the other one, but both of these are the answer. Both of these could potentially be the answer. It really just depends on what your instructor wants. Let's try another one. I want to try one that is a trig function. These become a little bit more interesting. Sometimes I find the trig ones are easier because it doesn't really require too much math. Let's try to set up the bookkeeping. I have u, right? Then I have the derivative, and then I have the letter a. This one's pretty interesting. So just to kind of show some insight, cosine x, its derivative is sine x. It gets a negative in the front. If I had sine x, its derivative is cosine x. The negative goes right here, right before sine. And there's some different methods of how to memorize that. There's another video that kind of showcases this. So right now, to the problem, we have u, which is going to be cosine x. The derivative is negative sine x. And this letter a, it doesn't look like there's anything there, but anytime you see log and there's nothing in the subscript, there is an understood silent 10. You're going to put that 10 there. So let's go ahead and set this up. Okay, so I have a 1 in the numerator. Then I have cosine x right in the denominator, ln 10, times the derivative, which is negative sine x. Let's make it with the invisible 1, and I get negative sine x over cosine x ln 10. So this could in fact be the answer, right? But you can further expand it. We can pull apart this fraction, and we can actually move it into two fractions. And I know this is a little bit tricky, but it takes a little bit of practice, right? I can do sine x over cosine x, right? So that's the first part, times 1 over ln 10. I just pulled them apart. So why did I do that? Well, if you look really, really carefully at negative sine x over cosine, you see that sine is on the top, which means we can convert it into tan. Don't forget that negative sign, because it came with a negative, so we're going to put the negative there. Times 1 over ln 10. There's nothing really you can do with ln 10, so you just keep it as is. We put that invisible 1 in the bottom, and now we just combine these guys, right? So I have negative tan over ln 10. Let's see. Perfect. So I'm going to put a box around this. So this is the answer, but this can also be the answer. Both are correct. Let's do another problem. This is similar in nature, although the u has been shifted, right? So let's see, we're going to do our bookkeeping. U, the derivative, and then the letter A. So let's take a look, right? So I have sine x, the derivative is going to be cosine x. And of course, if we had cosine x, it's going to be negative sine x. So let's take a look. I have sine. I'm going to put that there for you. And the derivative is cosine x. It's just positive cosine x. There is no negative, right? The letter A, well, if there's nothing written in the subscript, the little number in the bottom, it's going to be a 10. By default, we always do a little 10. So let's try to put it all together. I have 1 in the numerator, right? I'm getting that from this formula right here. 1 in the numerator. The u is sine x times ln 10, right? Perfect. Times the derivative, which is cosine x. Let's go ahead and do that in invisible 1. And we're going to multiply the numerators together, which is cosine x. And then I have sine x ln 10. This is the answer right here. But, of course, we can go further. We can pull these apart like we did with the previous, right? Cosine x, sine x times 1 over ln 10. So let's see, cosine x, when you have a cos on top, it becomes cot, C-O-T, which is cotangent. It stays positive because we don't have any negative symbols, right, in that particular term or fraction. And we're going to multiply it by 1 over ln 10. We use that up. We're using that up. Let's see. Let's do that invisible 1. We multiply the numerators together. So we have cot x, and then I have ln 10. This is also the answer. Both of these are correct. So with this fraction, the top one, right, that we worked on originally, I mentioned, hey, we can extract it, pull apart the fractions. How did I know to put cosine and sine together and then do the ln 10 by itself? How did I know to do that? Why not just mix it up a little bit? Why not cosine x, ln 10x on top? Or ln 10 on top, right? Why not all those together and then just sine by itself? Well, one of the things is that you kind of have to know what you're looking for. And I know that's like a very abstract idea I just shared. So in order for you to kind of get some clarity on what direction to go to, when to pull things apart, when to keep things, it just takes practice. And that's for everybody. Even like your professors and teachers, it just takes practice. You got to go through the homework problems and kind of see what the answer is, see if you got the correct answer. And it'll give you some insight. about what the next step is. Sometimes you're able to kind of guess what the next step is before you even work on it. That's just the nature of some of these math problems. I want to go over one more that kind of gives you a little bit more clarity. I hope you kind of solidify this formula. Here I have log, and then I have 8 in the subscript, right? It's pretty much the same thing we just worked on. Instead of an invisible 10, I have an 8. So let's try to work on this problem. So we're going to do our bookkeeping. I have u, then I got that derivative, and I have the letter a. So u is sine, right? Sine x, its derivative is cosine x. Let's see. And the derivative is cosine, and this time the letter a is going to be an 8. Let's set it up. I have 1, then I have sine x in the denominator, ln 8, right? So whatever the letter a is, that is what goes inside. So then I have the derivative, which is cosine x. What does that make? It makes cosine x sine x ln 8. Right? So this is the appropriate answer. This can, in fact, be the correct answer. But, if you look closely, you see that we have cosine and sine. Both of those together, when you mix cosine and sine, it makes cot x. Right, so we got rid of that part, but we still have this other part dangling in the bottom part of the denominator. Well, we can just keep that, right? 8. And then this can be the answer. Why did I put ln 8 in the bottom and not the top? Well, when you pull out these fractions right here, when it's cosine x, and then it's sine x ln 8, what happens is these two end up together, and there's an invisible little 1 here. That's why the ln 8 is at the bottom, and then cot is at the top, because if I did cot x times the fraction that stays exactly as it is, I have to put that invisible 1 in the bottom, and then cot goes on top, and then ln 8 goes on the bottom. That's why I decided why one is on the bottom over the other. So this is the answer, and then this is also the answer. Both are totally correct. Okay, guys, I hope this helped. Take care. Bye.